I have a dream that one day
Hi there everyone, welcome to this lesson on quadratic inequalities. In this lesson, we want to look at perfect squares in the context of quadratic inequalities. Then secondly, extended perfect squares. Thirdly, difference of squares. And lastly, trinomials. Example 1 here on quadratic inequalities deals with some very basic perfect squares. And it says solve for x in each of the following, and we are given these 6 inequalities. So let's look at the first one. We have to solve for x, and we are told that x squared must be greater than or equal to 0. So we are looking for x values such that when we square them, we get an answer that's either positive or equal to 0. So either positive, in other words, greater than 0, or equal to 0. Now, we know that any negative real number squared will give a positive answer. We also know that any positive real number squared will give a positive answer. Then we know that 0 squared, now 0 is also a real number, 0 squared will give us 0. So we can see from this that any negative real number, or any positive real number, or 0 will satisfy this inequality. And hence our answer is x is an element of real numbers. We can also write this in interval notation as follows. X will be an element of this interval. We call it an open interval using round brackets. X is an element of this interval which includes all the real numbers. So going from negative infinity to positive infinity. So this is expressing the answer here in interval notation. Now, to get more insight into this inequality, let's look at it from a graphical point of view. So we're going to draw a graph, and we're going to draw the graph of y equals x squared. So let's do that. We know that the graph of x squared, y equals x squared, is a parabola, and it looks as follows. Something like this. Now, in answering this question, for which values of x will x squared be greater than or equal to 0? We are asking the question, for which x values will the graph of y equals x squared either be positive, in other words above the x-axis, or equal to 0. And we can see that for any x value, the graph will either be positive, in other words above the x-axis, or 0. Hence we have this answer that x is an element of real numbers. Let's look at the second inequality. we have x squared is strictly greater than 0. And we must find the value of x. So x squared strictly greater than 0 or positive. We're looking for numbers that when we square them, we get a positive answer. Now once again we know that any negative number squared is going to give us a positive answer. And any positive number squared will give a positive answer. 0 squared, of course, will give us 0. Now, we can see that any negative or positive real number squared will give a positive, so will satisfy this inequality. 0 squared won't satisfy the inequality because 0 squared is 0, and we want an answer to be strictly greater than 0. So then, x will be an element of real numbers, but x cannot be 0. And just to reiterate, x cannot be 0 because 0 squared won't give us a positive answer. It will give us 0. We can once again express this in interval notation as follows. So x will be an element of these two intervals. The first one will go from negative infinity to 0, but excluding 0. So we use round brackets to exclude 0. X will be an element of this interval together with this interval from 0, but once again excluding 0, to positive infinity. Now we can combine these two intervals. In other words, x will be an element of these two intervals combined, and we can combine them by writing them as the union of the two. So x is an element of the union of these two intervals. Let's say we want to express this solution on a number line. We draw the x-axis. We're going to exclude 0. Now we draw a circle at 0 to show that we are excluding 0. And we draw an arrow pointing to the right of 0 to show that it's all positive real numbers. And then also an arrow pointing towards the left of 0. In other words, we're including all negative real numbers. Now, we said this symbol is known as the union. So it's the union of these two intervals. And we use this to combine the two intervals. Union also means or. So x will be an element of this interval or of this interval, but not including 0. And this here will be the x-axis. Let's look at the third inequality. We have x squared plus 7 strictly greater than 0. In other words, positive. Now, we know that any negative number or positive number squared will give a positive answer. And then when we add 7 to it, the answer will still be positive. So from that, we can see that any negative real number will work, as well as any positive real number. Because when we square it and we add 7, we get an answer greater than 0 or positive. 0 will also work because when we square it, we get 0. And when we add 7 to it, or 7 to the answer, we'll get 7, which is also greater than 0. So once again, any negative or positive real number will work, as well as 0. So in this case, our answer will be x is an element of real numbers. And we could express it in interval notation as we did over here. Then looking at D, we have x squared plus a squared strictly greater than 0. And we are also told that a isn't equal to 0. Now, what we have on the left-hand side of this inequality is a sum of two perfect squares. Now, the sum of two perfect squares will either be positive or equal to 0. It will only be equal to 0 if both x and a are 0, because then we'll get 0 squared plus 0 squared, which we know is 0. So the left-hand side here will only be 0 if both x and a are 0. But we are told that a isn't 0. So x squared plus a squared will never be equal to 0. And we said that the sum of two perfect squares are either positive or 0. We've now excluded the possibility of it being 0. So we can see that x squared plus a squared will always be greater than 0, no matter which real numbers we use for x and a. Of course, excluding a equals 0. So in this case, any real numbers will work for x and a, but we are solving for x, so then x is an element of real numbers. Let's look at E. We have x squared strictly less than 0. So we're looking for a real number or for real numbers such that when we square them, they are less than 0, or the answer is less than 0 or negative. Now, no real number squared will ever give a negative answer. So in this case, there's no solution to this inequality. So no solution. Let's look at the last inequality. We have x squared plus a squared strictly less than 0. So we need to solve for x such that x squared plus a squared is negative or less than 0. Now, the left-hand side here is a sum of two perfect squares. And we already said that the sum of two perfect squares will either always be 0 or positive. It can never be negative. So once again, in this case, there will be no solution to this inequality. So no solution. So let's look at your answers to this question. We had to solve for x in each of these inequalities. So in the first one, 3x squared is greater than 0. We can start by dividing through by 3, and we get x squared is greater than 0. So we are looking for an x value or x values that when we square them, we get an answer that's positive or greater than 0. Now, once again, every negative number squared will give a positive answer, and every positive number squared will give a positive answer. 0 squared will, of course, give 0, but this is strictly greater than 0. So any negative or positive real number would work here. So then x is an element of real numbers, an element of real numbers, but x cannot be 0. Because 0 squared will give us 0, and here x squared must be strictly greater than 0. Then looking at the second inequality, we have a half x squared is less than 0. Now we can first multiply both sides by 2, and we get x squared is less than 0. 2 times 0, of course, is 0. In this case, we're looking for an x value or x values such that when we square them, we get a negative answer. We know that no real number squared will give a negative answer. So in this case, there's no solution. So no solution. Let's look at C. Here we have that 4x squared plus 5 must be greater than 0, in other words positive. Now we know that 4x squared is going to be either 0 or positive. It's 0 when x is 0, and it's positive when x is any number other than 0. So let's say x is 0, then we get 0 plus 5, which is positive. If x is either positive or negative, but not 0, then we get a positive number here plus another positive number, which is also positive. So in this case, any value of x will work. In other words, any real number. So in this case, x is an element of real numbers. Let's look at the last inequality. So D. We have to find x such that x squared plus 1 is either less than 0, in other words negative, or equal to 0. Now x squared is a perfect square, so it's either going to be 0 or positive. So 0 plus 1 will give us a positive answer, and a positive number here plus 1 will also give us a positive answer. So x squared plus 1 will never be less than or equal to 0 for any real value of x, whether x is negative or positive or 0. So in this case, there's no solution. So no solution to this inequality. Example 2 on quadratic inequalities deals with perfect squares that are slightly more complex. We have to solve for x in each of these 4 inequalities. So let's look at the first one. We're told that x minus 1 all squared must be strictly greater than 0. Now, we know that any real number squared will be either 0 or it will be greater than 0, in other words positive. So we need to find out for which value of x the left-hand side here will equal 0, and then we have to exclude that value of x. So x minus 1 is equal to 0 when x is equal to 1. In other words, the solution to this inequality will then be x is an element of real numbers, but x cannot equal 1. So any real number that we substitute in for x here will give us a positive answer, and hence will be greater than 0, except for x equals 1. Now, we can also write this in interval notation as follows. We can write x as an element of 2 intervals, or the union of 2 intervals. The one interval will be from negative infinity to 1, and the other interval will be from 1 to positive infinity. The round brackets, of course, mean that we are excluding 1, and it's the union of these 2 intervals. Then we can also illustrate this on a number line as follows. The dark blue line is the real axis, and the light blue line represents a solution to this inequality. You can see that we have a circle at 1, an open circle, and that means that we are excluding 1 as an answer. So the solution is all the numbers to the left of 1 and all the real numbers to the right of 1. And it's excluding x equals 1. Let's look at the second inequality. So here we have x minus 3 all squared must be greater than or equal to 0. And we need to find x. Now, we know that any real number squared is either going to be greater than 0, in other words positive, or it's going to be equal to 0. So it doesn't matter which value of x we plug into the left-hand side here. Because we have a square outside the brackets, it's going to be, the left-hand side is going to be either positive or equal to 0. So in this case, the answer is x is an element of real numbers. In other words, all real numbers will work. We can also write this, of course, in interval notation as follows. X is an element of this open interval going from negative infinity to positive infinity. We can also illustrate this on a number line. The light blue line represents the solution to this inequality, and there are no gaps in this line. In other words, it represents all real numbers. Let's look at the third inequality. So here we have x squared plus 6x plus 9 is greater than 0. Now the left-hand side here is a trinomial that's a perfect square. Recall a perfect square is a trinomial in this form. A squared plus or minus twice ab plus b squared. And notice that the third, or the middle term here rather, is twice. So the middle term is twice the square root of the first term. So twice a squared times the square root of the third term, which is the square root of b squared. So this is a trinomial here on the left-hand side, because if we look at 6x more closely, then it's equal to twice the square root of x squared times the square root of 9. Then also remember that when we have a trinomial that's a perfect square, we can factorize it as follows. It's going to be the square root of the first term, in other words a, plus or minus the square root of the third term, in other words b, all squared. Since we know that this is a perfect square on the left-hand side, or a trinomial that's a perfect square, we can factorize it in this way. So it's a square root of the first term, which is x, the middle term sign, which is a plus, and the square root of the third term, which is 3, and this is all squared. This must be greater than 0. Note that it's strictly greater than 0. Once again, we know that any real number squared will be either greater than 0 or equal to 0. So the question is, for which value of x will the left-hand side here be equal to 0? We can work it out. X plus 3 equals 0 means that x is equal to negative 3. So then the solution to this inequality will be x is an element of real numbers, but x cannot equal negative 3. Then coming to the last inequality, we have x plus 7 all squared must be less than 0 or negative. No real number squared will ever give a negative answer. So in this case, there's no solution to this inequality. So no solution. So let's look at your answers to this question. In A, we have x plus 5 all squared is strictly greater than 0. We know that any real number squared will give an answer that's either greater than 0 or positive or equal to 0. In this case, the left-hand side is strictly greater than 0 or positive. So we need to see where the left-hand side equals 0, and then we need to exclude that from our answer. We know that x plus 5 equals 0 when x is equal to negative 5. So when x is negative 5, the left-hand side is equal to 0 and not strictly greater than 0. So in this case, our answer is x is an element of real numbers, but x cannot equal negative 5. Then, to give the answer in interval notation, x will be an element of the union of two intervals. So x is an element of the interval from negative infinity to negative 5, excluding negative 5, union the interval from negative 5, excluding negative 5, to positive infinity. So x is the element of the union of these two intervals. So we have negative 3 into x minus 1 all squared must be less than or equal to 0. We can first get rid of the negative 3 in front of the brackets by dividing through by negative 3. So we get x minus 1 all squared. And when we divide an inequality through by a negative number, the inequality sign will switch around. So it's going to be greater than or equal to 0. Of course, 0 divided by negative 3 is 0. So we end up with x minus 1 all squared must be greater than or equal to 0. And we know that any real number squared will be greater than or equal to 0. So any value of x will work here. So then the answer is x is an element of real numbers. Let's look at C. So we have 2 minus x all squared over 5 is strictly greater than 0. We can start by getting rid of the 5 on the left-hand side by multiplying through by 5. So we end up with 2 minus x all squared is greater than, and 0 times 5 is 0. We know that any real number squared will be greater than or equal to 0. In this case, we want the left-hand side to be strictly greater than 0 and not equal to 0. So we're going to check where the left-hand side equals 0. So we're going to solve this equation. 2 minus x equals 0. And hence, minus x or negative x is negative 2. And then dividing through by negative 1, we see that x is equal to 2. So then the answer to this question will be x is an element of real numbers, but x cannot equal 2. Because when x is 2, the left-hand side equals 0. And we are told that the left-hand side must be strictly greater than 0. Then, to illustrate this on a number line, so let's say this is the real axis. We're going to exclude 2. So we're going to need an open circle at x equals 2, and then arrows pointing to the right or towards the right of 2 to positive infinity, and then towards negative infinity. So to the left of 2. So this will be a number line that illustrates the solution. Then looking at D, we have 2/3 x plus 9 all squared is less than 0. We know that no real number squared can ever be less than 0 or negative. So in this case, there is no solution to this inequality. So no solution. Let's look at the last inequality. So E, the left-hand side here is a trinomial that is a perfect square. Because the first term is a perfect square, the third term is a perfect square, and the middle term here is twice the square root of the first term times the square root of the third term. So then we can factorize this as follows. We can take the square root of the first term, which is 2x, the middle term sign, and the square root of the third term, which is 3. And this is all squared, and this must be greater than 0. So strictly greater than 0. So as usual, we're going to check where the left-hand side equals 0. So we're going to do this on the side. And we can solve this equation. We find that x is equal to 3 over 2. So then the answer to this inequality, it's going to be x is an element of real numbers, but x cannot equal 3 over 2. Because when we plug in 3 over 2, the left-hand side will equal 0 and won't strictly be greater than 0. So x is an element of real numbers, but excluding 3 over 2. In this example, we want to look at quadratic inequalities that involve a difference of squares. So it says solve for x in each of the following, and we are given these 4 quadratic inequalities. So let's look at the first one. So here we have x squared minus 4 is less than or equal to 0. Now, before we look at this, we just want to revisit a difference of squares. We know it's an expression in this form, a squared minus b squared. In other words, a perfect square minus a perfect square. And we know that to factorize this, it'll be a minus b times a plus b. In other words, it's a square root of the first term minus the square root of the second term in the first set of brackets, and then the square root of the first term plus the square root of the second term in the second set of brackets. So we can apply this factorization to the left-hand side here, and we'll get x minus 2 times x plus 2. And this is less than or equal to 0. There's more than one way in which you can solve this inequality from here. We can use a table or we can use a graph. Personally, I prefer to use a graph. I think it's easier. So we're going to draw a rough sketch of y equals x squared minus 4, which of course is a parabola, and we're only really interested in the roots of the graph. So the roots are plus 2 and minus 2. So we can draw a rough sketch of this parabola with the roots. So negative 2 and positive 2. Now, what does this inequality really mean? It says x squared minus 4 must be less than or equal to 0. So this means that the graph of y equals x squared minus 4, in other words, this graph, must be either 0, or it must be negative, in other words, below the x-axis. So this region over here. And we need to solve for x. So we need to find the values of x for which the graph is either 0, in other words, cutting through the x-axis, or negative, in other words, below the x-axis. And we can see that for all x's between and including negative 2 and 2. So all these x's. So then our answer will be x will be between or greater than or equal to negative 2, but less than or equal to 2. So between negative 2 and 2, including negative 2 and 2. To illustrate this with interval notation, we'll say that x is an element of, in this case we use square brackets to show that it includes -2 and 2. So x is an element of this interval, which is also called a closed interval. So the interval from -2 to 2, inclusive of -2 and 2. Then let's say we had to illustrate this on a number line. Let's do that. So this will be the real axis, or the x-axis. And we are interested in the points -2 and +2. And it includes all values between -2 and +2. So we're going to have a solid line from -2 to +2. And then at -2, we're going to have a dot, so a circle that's colored in, as well as at +2, to show that it includes the values -2 and +2. Let's look at the second inequality. So we have x squared is greater than 3, and we need to solve for x. We can always bring everything to the left-hand side. So it's x squared minus 3 greater than 0. This is not obviously a difference of squares, because 3 is not a perfect square. However, we can turn this into a perfect square as follows. So we can write it as x squared minus the square root of 3 all squared. The square root of 3 all squared, of course, will give us 3. Now it's a difference of squares, and we can factorize it as such. So we can write x minus the square root of 3 times x plus the square root of 3. This is greater than 0. Now we can draw a graph. So let's do that. So we can draw a rough sketch of this graph. We're only interested in the roots. So the roots are negative the square root of 3 and positive the square root of 3. We want to know where the graph of y equals x squared minus 3, in other words, this parabola, is greater than 0 or positive. So where is it above the x-axis? And we can see that to the right of the square root of 3, it rises above the x-axis, as well as to the left of minus the square root of 3. So for all the x's to the left of negative the square root of 3, and for all x's to the right of positive the square root of 3. So then our solution will be x is less than negative the square root of 3, or x is greater than positive the square root of 3. If you wanted to illustrate this as interval notation, x will be an element of, now to the left of -3, we're going towards negative infinity. So from negative infinity to negative the square root of 3, then we have the union. So it's this interval. We have the union of this interval with this one. In other words, with from positive square root 3 to positive infinity. And if you wanted to illustrate this on a number line, we do it as follows. So let's say this is the real axis, or the x-axis. Our 2 points of interest will be negative square root 3 and positive square root 3. So we'll have a line pointing to the right of positive square root 3. But in this case, we don't include positive square root 3. So we have an open circle. We're excluding the square root of 3. And the same with negative the square root of 3. We're excluding it. So we have a line pointing this way. So typically in a test or exam, when we answer this question, we can either give the solution like this, or if we ask for interval notation, we'll give it like this. And if we ask to illustrate it on a number line, we'll give the solution like this. Let's look at the third inequality. Here we have 16 minus x squared is less than or equal to 0. We're going to start by rewriting the order of the terms on the left-hand side. We always want to write the x squared term first. So it's going to be negative x squared plus 16 is less than or equal to 0. Then secondly, we always want a positive x squared coefficient. So we're going to multiply through by negative 1. So we end up with x squared minus 16. And since we are multiplying through by a negative number, the inequality will switch around. So now we have a nice difference of squares here, which we can factorize as such. So it's going to be x minus 4 times x plus 4 greater than or equal to 0. We can now draw a parabola. So we're going to draw the parabola y equals x squared minus 16. Now the roots here are negative and positive 4. So negative and positive 4. Now, what does this inequality really mean in terms of the graph? It's asking for which values of x will the graph of y equals x squared minus 16 be either equal to 0 or positive, in other words, above the x-axis. Of course, at positive and negative 4, it's 0, in other words, where it cuts through the x-axis. And then for values of x greater than 4, it rises above the x-axis. So over here, as well as for x values below negative 4 or less than negative 4. So here it also rises above the x-axis and hence is positive. So then our solution will be all x values above 4 or greater than 4, but also including 4, and all x values below 4, or rather below negative 4, but also including negative 4. So we can write down the solution. X will be less than or equal to negative 4, or x will be greater than or equal to positive 4. We can also illustrate this with interval notation. So x will be the union of these two intervals, or it will be an element of the union of the two intervals. X is an element of, now x value is less than or equal to negative 4. We can illustrate with this interval going from negative infinity to negative 4, but including negative 4. And we always exclude positive or negative infinity. So we're always going to have a round bracket on the side of positive or negative infinity. Then it's a union with the second interval, in other words with this interval, which goes from 4, but including 4, to positive infinity, but once again excluding positive infinity. Then if we had to illustrate this on a number line, so let's say this is the real axis, we have negative 4 and positive 4. In this case, it's going to include positive and negative 4. So we're going to have a colored in circle at positive and negative 4 to show that it includes negative and positive 4. And then you will have an arrow pointing towards positive infinity from 4 and towards negative infinity from negative 4. Let's look at the last inequality here. So number 4, we have 2x squared minus 18 is less than 0. Now, we don't have a difference of squares on the left-hand side. We have a common factor of 2 though, so we can divide through by 2. And we get x squared minus 9 is less than 0. On the left-hand side, we now have a difference of squares. So we can factorize it as x minus 3 times x plus 3 less than 0. Now we can draw a parabola. The roots, of course, are negative and positive 3. Now, looking at this inequality here in terms of the graph, it's asking for which values of x is the graph of y equals x squared minus 9, negative or below the x-axis. And we can see that from negative 3 to positive 3, it's below the x-axis. So then our solution will be all the x values from negative 3 to positive 3, but excluding negative and positive 3. In other words, it will be the sandwiched inequality. X is greater than negative 3, but less than positive 3. Once again, if we had to illustrate this with interval notation, it will be x is an element of going from negative 3, but excluding negative 3, to positive 3, and once again excluding positive 3. The solution on a number line will look as follows. It's going to be a solid line from negative 3 to positive 3, but we have open circles at negative and positive 3, showing that we are excluding these two values. Let's look at your answers to this question. So in the first one, we have x squared is less than or equal to 25. We can start by bringing the 25 to the left-hand side. Now we have a difference of squares on the left-hand side. So we can factorize. We can draw a parabola, so a rough sketch. And in this case, the roots are positive and negative 5. Now, we want to know where the graph of y equals x squared minus 25 is either 0, so at negative and positive 5, or less than 0. In other words, below the x-axis. So we can see for all x values from -5 to +5. So the solution here will be x is in between and including negative and +5. Then we can also write this in interval notation as follows. So x will be an element of the closed interval. In other words, including -5 and +5. So the closed interval from negative to +5. Then we can also draw a number line to illustrate the solution with. So it's going to be -5, +5, and we're going to draw a dot at positive and -5, and then a line connecting the two dots. So all x values from -5 to +5, including negative and +5. Let's look at B. So we have 7 minus x squared is less than 0. We're first going to rewrite the order of the terms on the left-hand side. So we're going to write the x squared first. So negative x squared plus 7 is less than 0. We want to have a positive x squared coefficient. So we're going to multiply through by -1. And we have x squared minus 7 is greater than 0. So the inequality switches around when we multiply through by -1. We don't have a difference of squares here, but we can create one. So we can write it as x squared minus the square root of 7 all squared. And that's greater than 0. Now we can factorize as a difference of squares. It's going to be x minus the square root of 7 times x plus the square root of 7. And this is greater than 0. We can draw the parabola now. So the roots are negative square root 7 and positive square root 7. We want to know where the graph of y equals x squared minus 7 is greater than 0 or above the x-axis. So we see that from -7 to the, or rather from negative square root 7 to the left or towards the left, it rises above the x-axis, and then from positive square root 7 towards the right, it also rises above the x-axis. So then our solution will be x is less than negative the square root of 7, or x is greater than positive square root 7. We can illustrate this in interval notation as follows. So x will be an element of this interval. In other words, from negative infinity to negative square root 7, together with, so the union of the square root of 7 to positive infinity, and excluding negative square root 7 and positive square root 7. Then on a number line, it's going to look as follows, the solution. It's going to exclude negative and positive square root 7, and it's going to be a line pointing towards the left from negative square root 7 and towards the right from positive square root 7. So in C, we have 4/3x squared is greater than 3. We can start by getting rid of the fraction here and multiply through by 3. So we get 4x squared is greater than 9. Now we can bring the 9 to the left-hand side. And we have a difference of squares, so we can factorize. The square root of 4x squared is 2x minus the square root of 9 being 3. And this, of course, is multiplied by 2x plus 3 greater than 0. Now we can draw a parabola. So the roots are negative 3 over 2 and positive 3 over 2. We want to know where the parabola is greater than 0 or above the x-axis. So to the left of negative 3 over 2, it rises above the x-axis, and also to the right of 3 over 2. And of course it excludes positive and negative 3 over 2. Then to write down the answer or the solution, x will be less than negative 3 over 2, or x will be greater than 3 over 2. If you wanted to illustrate this in interval notation, it's going to be the union of these two intervals. So x is an element of the open interval from negative infinity to negative 3 over 2, together with the interval from 3 over 2 to positive infinity. So basically these two intervals. Then to illustrate it on a number line, it's going to exclude negative and positive 3 over 2 to the left of negative 3 over 2 and to the right of positive 3 over 2. Then coming to the last inequality, we have that 3x squared minus 27 is greater than or equal to 0. We don't have a difference of squares on the left-hand side, but we can divide through by 3, which is a common factor, and we get x squared minus 9 is greater than or equal to 0. Then factorizing, it's going to be x minus 3 times x plus 3 greater than or equal to 0. Now we can draw the parabola. So in this case the roots are negative and positive 3. And we want to know where this parabola, y equals x squared minus 9, is either equal to 0 or positive, in other words above the x-axis. So we can see to the left of negative 3 and to the right of positive 3, it rises above the x-axis. So then our answer will be x is less than or equal to negative 3, or x is greater than or equal to positive 3. Then as interval notation, it's going to be the union of these two intervals. So from negative infinity to negative 3, union 3 to positive infinity. And then to illustrate this on a number line, we're going to use a colored in circle or a dot to show that we are including negative and positive 3. And then we're going to have lines going to the right from positive 3 and towards the left from negative 3. Let's look at your answers to the additional question here. In the first one, we have x squared minus p less than or equal to 0. We can turn the left-hand side into a difference of squares by writing it as follows: x squared minus the square root of p all squared less than or equal to 0. Now we can factorize the left-hand side as a difference of squares. It's going to be x minus the square root of p times x plus the square root of p less than or equal to 0. We can now draw a parabola. Of course, our roots will be negative and positive square root p. So the graph will look something like this. So minus square root p will be the one root, and positive square root p will be the second root. And we want this parabola to be less than, in other words, negative, less than 0 or negative. So either less than 0 or equal to 0. Now we can see from the graph that the parabola is equal to 0 at these 2 points, at negative and positive square root p, and it's less than 0 or negative for this region. In other words, for all x's between negative and positive p, or negative and positive square root p. So we can write on the answer, x will be greater than or equal to negative square root p, but less than and equal to, or less than or equal to positive square root p. We could also give this in interval notation as follows. X will be an element of, now including negative square root p to square root p, and also including square root p. So x is an element of this interval that goes from negative square root p to positive square root p, inclusive of both. Let's look at the second inequality. We have ax squared minus b strictly less than 0. We are also told that both a and b are greater than 0 or positive. We're going to start by dividing through by a. So we get x squared minus b over a less than 0. We know that the inequality sign doesn't switch around when we divide through by a, because a is positive. Now we're going to turn the left-hand side of this inequality into a difference of squares. So we're going to rewrite it as x squared minus the square root of b over a all squared. We can factorize the left-hand side now as a difference of squares. So it's x minus the square root of b over a times x plus the square root of b over a less than 0. At this stage, we can draw a parabola. So just a rough sketch. Now our roots will be plus and minus square root of b over a. So let's draw that. So minus the square root of b over a and positive square root of b over a. We want the parabola to be negative, less than 0. In other words, below the x-axis. And we see that for this region, it's going to be below the x-axis, or negative. So we can write down the answer. It will be for all x's between this point and this point over here, all the x's. So then our answer will be x is greater than negative square root b over a, but less than positive square root b over a. If you had to put this in interval notation, we would write as follows. X is an element of the open interval. So not including these 2 points. The open interval from negative square root b over a to positive square root b over a.